Hey everyone, and welcome to today's Explainer. I am absolutely thrilled to have you here. Today we're unpacking something that is honestly a massive game changer for small business owners, developers, and really just tech enthusiasts in general. We're looking at a fantastic GitHub project by Pavanteya. Basically, it acts as a blueprint for using the Llama 3 model to build a fully local, privacy-first AI customer support chatbot. And the best part? You absolutely do not need a massive enterprise budget to make this work. Stick around and you'll see exactly why.
Okay, let's be real for a second. For a long time, if you wanted to tap into the power of large language models, you basically had to rely on these massive, super expensive cloud providers, right? You were paying for every single API call, and honestly, worse than that, you had to send all your sensitive customer data off to some external server. But what if we just flipped that script? What if your AI costs literally $0 and guaranteed 100% privacy? Well, that is the exact problem this local chatbot project solves. It is pretty much the ultimate setup for small businesses that want to adopt AI, but without all those financial insecurity headaches.
All right, here's our roadmap for today. 1. The offline AI advantage. 2. The chatbot tech stack. 3. Local deployment. 4. Zero-shot versus one-shot prompting. 5. Evaluating performance. And 6. Advantages and limitations.
Let's jump right into Section 1, the offline AI advantage.
When we're talking about customer support here, we aren't talking about having deep, philosophical conversations with an AI. We're talking about the daily grind of e-commerce. You know, the repetitive stuff? This offline chatbot is specifically tailored to handle 4 high-volume areas: order tracking, returns and refunds, product inquiries, and payment issues. These are the exact types of queries that usually eat up hours and hours of human support time. By routing these specific tasks to a local AI, businesses can instantly automate their frontline support and do it completely offline.
So the crucial point here is that massive zero. Running this entirely on local hardware means zero API costs. None. You aren't paying a fraction of a cent per word generated. And arguably even more important, there are 0 instances of your data ever leaving your system. Look, in a world where data privacy regulations are just getting stricter by the day, keeping everything offline like this, it's absolutely huge.
Okay, moving on to Section 2, the chatbot tech stack. Now, if you've ever felt intimidated by AI development, and let's be honest, it can be a lot, this tech stack is going to be a total breath of fresh air. I want to completely demystify this setup for you. The entire logic of this project, it's built using 100% Python. There is no convoluted, proprietary enterprise software anywhere in sight. It just relies on Ollama, the Llama 3 model itself, and the standard Python request library to handle the communication. That's the whole shebang. It's all built on very accessible, standard REST API integration.
Now, you might be wondering, what on earth is a llama? Well, a llama is essentially the engine making all of this magic happen. It's a tool that takes the incredibly heavy, complex weights of a large language model like Llama 3 and actually serves it directly on your local machine. It basically lets you interact with it just like you would a standard cloud service. It perfectly bridges the gap between those massive AI models and your everyday computer hardware.
Which brings us to Section 3, local deployment workflow. You're going to love how surprisingly simple it is to get this running. First up, you just install a Llama. Simple enough. Then step 2, you run a quick command to pull the Llama 3 model right to your machine. Step 3 is just setting up a standard Python virtual environment, followed by step 4, installing your requirements, which, by the way, is literally just the requests library. And finally, step 5, execute the chatbot.py script. Boom, 5 steps. Honestly, it takes about 5 minutes, and you've spun up a local LLM from scratch. I mean, we used to spend months deploying enterprise customer service software, right? Now it actually takes longer to brew a pot of coffee.
So what exactly happens the moment you hit run on that script? Well, this workflow is the internal magic. The Python script takes your predefined customer queries, uses that requests library we talked about to shoot them over to your local Ollama API, which then prompts the Llama 3 model to generate a response. And once it's generated, the system automatically saves those responses straight into a markdown file in your evaluation folder. It's just a beautiful, seamless, self-contained loop.
All right, Section 4, zero-shot versus one-shot prompting.
Now, this is where things get really fascinating. How do we control the AI's behavior without constantly rewriting its underlying code? We use prompt engineering. The project actually tests 2 specific templates. Zero-shot prompting, that's when you ask the AI a question directly, basically giving it 0 prior examples of how you want it to answer.
One-shot prompting, on the flip side, is when you provide the AI with exactly one really strong example of a good interaction right before asking your actual question. And the findings detailed in the project are honestly eye-opening. When the chatbot was given 0 examples, 0 shot, the Llama 3 responses were technically accurate, sure, but they were super generic. But the moment they gave the AI just a single example of a good support interaction, one-shot prompting, the quality literally skyrocketed. The responses suddenly became incredibly structured, highly helpful, and perfectly tailored to a customer service tone. Just one single example fundamentally changed the whole quality of the output.
Let's look at the grades in Section 5, Evaluating Chatbot Performance.
Because look, you can't just trust an AI blindly, right? You have to grade it. To do that, the author used 3 manual scoring metrics to evaluate the final report. First, they looked at relevance, meaning how accurate was the response to the specific customer query. Then coherence, making sure the clarity and readability were actually up to standard human levels. And lastly, helpfulness, measuring if the response actually provided practical, real-world usefulness to the hypothetical customer.
So, after putting the generated responses through that grading matrix, what was the ultimate verdict? Quote, local LLM performed well for basic support queries. Guys, this is huge. It completely proves that you do not need a massive, hyper-expensive, internet-connected model to successfully handle standard, everyday customer service tasks. The local, completely free option is actually highly capable.
Bringing us to Section 6, Advantages and Limitations. Obviously, we have some incredible, almost unbeatable benefits here. Absolutely 0 API costs and 100% privacy, because again, no data ever leaves your computer. But to be fair, we do have to balance that against the practical limitations. Running this on a standard CPU instead of specialized cloud hardware? Yeah, it means slower response times. And because it's offline, it has no real-time data integration, meaning it can't just check a live tracking number database on its own yet. Plus, as with literally all LLMs out there, there's always that risk of hallucination, where the AI confidently just makes up an incorrect response. But don't worry, the author isn't stopping there. They have a really clear roadmap to evolve this from a simple terminal script into a fully fledged business tool. Future improvements include adding a graphical Streamlit user interface, actually connecting the script to a real database so it can look up live orders, refining that prompt engineering even further, and this is super cool, adding multi-language support. So one local model could potentially serve your customers globally. So let me leave you with this final thought. We've seen the code, we understand the massive privacy benefits, and we've looked at those really impressive one-shot prompting results. If you could deploy a highly capable, zero-cost, fully private AI assistant on the hardware you literally already own today, how might that change the future of your business operations? It's a wildly fascinating question, and thanks to brilliant projects like this one, it's a future we can actually start building right now. Thank you so much for joining me on this explainer, and I can't wait to explore our next topic with you soon.